Okay, so we'll start with this worksheet. I think we know how to do this worksheet. So we'll do number 1 together. And if you're trying to race ahead, as warm-ups, we're going to do 1, 3, 5, and 7. As warm-ups, we'll do 1, 3, 5, and 7. So let's do number 1 first. Let's see, 16 to some stuff, 16 to some stuff. What can we do with the exponents if they have the same base? We can add them. So this will be 16 to the, let's see, if I add all of that, that would be x minus 4. Equals 64. You don't, right? Because if you have x squared times x cubed, that's not x to the 6th. That's 2 x's and 3 x's make 5 x's. So we add them. Now when we get here, this is like the nickname problem. It's like 16 has a nickname and 64 has a similar nickname. Like, what else could we call 16?
4 squared.
4 squared. And what about, well, one at a time. Yeah, 4 cubed on the other side. So 4 squared is 16. 64 is 4 cubed. That way, now they have the same base. Yep, first distribute the 2. And if you make it this far, this is where you don't have to really understand exponents to know what's your next step going to be. I mean, if 4 to something equals 4 to something, the two somethings got to equal each other. So add 8 to the other side, divide by 2, 11 halves. Okay, so you try 3, 5, and 7. Number 5. Okay, what's the exponent on 36? 1. Oh, there. So the left-hand side is 36 to the 1 plus k. And then I think I can make both of those have a common base. 36 is 6 squared. 1 plus k. And what about 1 over 6? What's another way to write that? 6 to the negative 1. So now I've got them both in terms of 6's. So let's distribute the exponent. So that's 6 to the 2 plus k equals 6 to the negative 2 plus 2k. And now we're down to the easy parts because now we've got the something equals something step. So the two exponents have to equal for this to work. So 2 plus k equals negative 2 plus 2k. Let's see, I would add 2 to both sides, and then subtract k from both sides, and get k equals 4. Brooklyn?
Why is it 2 plus k and not 2 plus 2k? On the...
Yep, good catch. 2 plus, yeah, I really messed that up. That's 2 plus 2k on this side. And on this side, it's negative 2 plus k. I was wondering why my answer didn't match Ava's when I thought she was right. So 2 plus 2k equals negative 2 plus k. There we go. So subtract the k over, subtract the 2 over, and k equals negative 4. Ava? Yes? Okay. Yeah, apparently I need to do some more of these as well. Number 7. 1/4 and 16, those look like they have something in common. How could I rewrite 1/4? 4 to the negative 1. So that's 4 to the x. And I would hope some of you just stopped right there. You're like 4 to the x equals 16. I don't need to go any further with that. That's just 2. But if you want to keep doing the same way we've done them, you would write that as 4 squared. And then it would be even more obvious that x equals 2. Questions on any of those? Okay, that was rougher than I had hoped. So let's try 2, 4, and 6. 2, 4, and 6. 2v minus v is v. So keep the 3. 2v minus v is v. So 3v equals, 3v equals 1. Brain was skipping ahead there. So you could, hopefully you look at that and you're like, well, v has to be 0 for that to work. You don't really need to try to rewrite 1 as something. That only works for v equals 0. The other way that people work this problem was to multiply both sides by 3 to the v, like that, like clear the fraction, and then you sort of automatically set up for the something equals something step. 2v equals v, but then you have to be able to solve that. So if I subtract the v over, I get v equals 0, and, well, either way, v equals 0.
Who has the highest average? Or like, who has a higher average that goes to the board?
I thought that was coming. I have no idea. I don't break things down that way. I mean, I could look around, but that wouldn't be wise. Eyeball test it. Number 4. Emery, how can I rewrite 64? 4 cubed. Ben, how can I rewrite 16?
4 squared.
4 squared. So 4 to the negative 9n equals 4 to the negative 4n. So there's my something equals something step. And if negative 9n equals negative 4n, what's the only value of n that will work for that? 0. Now, if you need to kind of go through the steps and convince yourself, that's fine. 0 equals 5n, so n equals 0. And then lastly, 1 over 81. How could I rewrite 1 over 81?
1 over 3 to the power 4.
Oh, there's different ways to go here. I think I heard 1 over 3 to the 4th. That would work. Which would be nice because then it matches the other side. Ava, were you thinking something different? Yes. So you could have done that as 81 to the negative 1. And then 3 to the negative 1. I'm jumping methods here. I would still need to fix this 81 as 3 to the 4th, so that is 3 to the negative 4. So negative 12v equals negative 1, v equals 1/12. That was that way to go. For you guys that left it as a fraction, that's fine. You'd have 1 over 3 to the 12v equals 1 over 3. So then you can say that 12v equals 1 and v equals 1/12. So either way, a couple ways to get there on that one. One way would be to kind of flip them so you're not dealing with fractions. The other would be like, well, they're both fractions, so let's just leave the fractions alone and go from there. Okay, I think I feel better about those after an extra 3.